Hello guys, welcome back. So my name is Sandip from askIITians, and we are going to continue our chapter which is light. We have already covered the two sessions on the light, right? So we already know about the light, then what is light and how we can see the objects, different objects, right? Then we also seen some materials objects, we can say transparent, translucent, opaque. What are those objects? What are their properties? Who is going to allow the light? So I hope you remember all those things very clearly. We have seen those part in this first session. In second session, we studied something about the mirrors, right? Plane mirrors, how we get the image from the plane mirror. Then about the spherical mirrors, how the spherical mirrors gives us the image. What are the distances? What are the formulas? We have seen those part too, right? Okay. So in this session, we are going to talk about the lenses. Right? So what is the difference between, let's say, mirror and lenses? Mirror obviously is going to give us some reflection there, right? And so we already know lens is what? It is, can we say it is something like the plain glass, right? Because glass is also allowing the light to pass, and lenses are also allowing the light to pass, right? If you do remember, I talked about the spectacles, right? The spectacles has some glass, right? Glass is what? It is a transparent object. It is letting the light to pass, right? Therefore, we can see the objects. But what is making them to look the object very clearly, right? Why we use the specs to, when we see the objects, blur objects, then we use the specs and then we can easily see those objects. So this is the reason. And what is the property of the specs? Why I can see the objects clearly with the specs rather than without the specs, right? So we have to use, we have to see those things. Those are called as the lenses, different lenses we are going to use, right? Also in the previous session, we studied about the different properties of the spherical mirrors. So similar to that, we can say what are the different properties of lenses. Let's talk about this in this chapter. Okay. So if you do remember, we have said there are two types of mirror, concave mirror, convex mirror, then how the images are formed, all those things. Similarly, there are two types of lenses are also there, right? Which are called as biconcave mirror, biconcave lens and biconvex lens. These are the two types of mirrors. Okay, we are going to see what is the formula for those. Focal length, what is the focal length? It's terminology is more or less similar to our mirrors case, we can say. Okay, so what we are going to see in this case is first of all refractive index. Refractive index means what? So there is a very special term there in this ray optics topic. We can say light topic. So not only on this in this standard, but even for the 11th, 12th, JEE exams, NEET exams, right? All those entrance exams will have this refractive index term, and a lot of numericals are based on this. Right? We are going to see what is that. Then laws of refraction. So we already know what is reflection, right? What is refraction, right? I have given you the example of the glass window. Light is coming through the glass window in the straight line most probably, right? But there is a small deviation, small change we can say in the path of the light, right? What is that change? We are going to see that, right? That is called as refraction actually, right? And what is total internal reflection and what is Lane's formula? All those things we are going to see today. Okay. So before moving, let me just have a small recap on the concave lens part and how the images are formed for those concave lens. If you do remember, we have created one table there for the concave lens, concave mirror actually, not the lens. Right. If you do, let's draw the here. So this is the mirror, this is the pole, this is the focus point, and this is the center of curvature. So the image depends on where we keep the object, right? So let's try to make that table again. Let's see whether you can remember the whole table, right? Why am I doing that? Because it is also related to lenses in this section also, right? Once you understood this concept of the mirror, then the lenses concept is also similar, right? Positions of image, where image will appear, and etc. and etc. right? So consider, first of all, if you keep the object at infinity, right? So object at infinity, you are going to get image. If you do remember, this is U, this is called as V, right? Image position, object position. So if you keep the object at infinity, you will get the image at focus point. Let's also talk about the nature of the image. Nature of image. Okay, nature of image means what we have seen in the yesterday's lecture is a previous session actually, right? That image could be on the left side or right side, right? Left side is called as the real side, right? Real side, or it is also called as in front of mirror, right? So this is the in front of mirror. This is called as virtual side or behind the mirror. Okay, so where what type of image we are getting, is it real, virtual, or if you do remember, we got some images which are inverted also, right? Or small size or magnified, right? Small size means diminished and magnified means big size, we can say, right? So we are going to write about that too. So when we keep the object at infinity, very long distance, rays will come something like this, and we are going to get image somewhere here, right? So image we are getting at focus point, right? And nature of images, remember, it is inverted. Inverted means what? It is upside down. So if you keep the object like this, you are going to get image something like this, right? Inverse. Okay, then it is on the real side, so we can say it is real, and we can also say it is highly diminished. Highly diminished means what? It is very small images will be there. Okay, this is happens when you keep the object at infinity. Now, consider if you keep the object between infinity to center of curvature. Center of curvature we know the radius is r, right? We also know the relation between r and f. R is equal to 2 times of f, right? Where f is what? F is focal length. And r is what? R is called as radius of curvature, right? So we know these things. Okay. So if you keep the infinity to c, means suppose you keep the image somewhere here. What you are going to get? This is the object, not image. You are going to get the image somewhere here, right? In between, we can see C and focal point. So we have also seen in the previous sessions there was very small animation, very cool animation, right? That if you move the image from infinity to, let's say, up to towards the focus point, object, not image, then image is going to move from focus point to infinity, right? So now initially it was infinity, you got the image at focus point right here. Now if you are moving the object towards the center of curvature, image is going to move here, but again it is smaller size, right? So I can say image will be formed between focus to center of curvature. Again it is inverted, you can see it is inverted, then real because in front of object, and diminish means smaller size. Same thing is going to happen. What will happen if you keep this image object on the center of curvature? Remember, in that case, you will get the exact image at the same point and also at this of the same side. So if you keep the object at the center of curvature, image will also appear on the center of curvature. Again, it will be inverted. Then it is same size, real also, and same size also. Remember this thing. Now, let's consider if you keep the object from C to F somewhere here. We know now the image is running away from it, from where, say, center of curvature to infinity, we can say, right? Image will be like this. So it is again inverted. We can say it is in front of mirror. So can I say it is real? Yes, it is real. And now you can see it is magnified. This is now magnified image. Okay. Next, we have, if you keep the image on the focus point on F, you are going to get the image, sorry, object on the focus point, you are going to get image at the infinity. Very simple. Again, it will be inverted. Real, we can say, and highly magnified in this case. Very bigger object you are going to, bigger image, we can say. and you should keep the object from focus point to pole. So somewhere here. Now this is the only case when you are getting the image of this object on the other side or behind the mirror, we can say, right? So this is called as behind the mirror, right? And the image will be, now in this case it is upside, or it is called as erected, means straight upward, we can say, right? Simple. And it is virtual. This is the only case we are when we are getting the virtual image. And again you can see it is a magnified image. So these are the different cases you should remember for the concave mirror, right? So remember, this is for concave mirror, and once convex lens, diagram will be different. Just don't worry about this. When we go up to the lens, then we will again come back to see this table, right? So this is about the concave mirror and what will be the objects and images position. Now similarly, let's talk about the convex mirror. So if you do remember, for convex mirror, there is only one position, only one condition you should remember, right? So object, image, and nature. We are going to do just only one condition there. Keep object anywhere from focal to or infinity to focal point. Doesn't matter where you keep the object. Image will be always virtual. This is real. Virtual means what? Behind the mirror, I can say it is behind the mirror. So it will be always virtual, and upright, you can say, and diminished means it will be smaller in size. Okay, so remember this part. Upright, let me say this is the upright instead of upside. Yes. Okay, so this is the object, image, and nature of the lens, we can say. For the, this is for what? This is our convex mirror. And remember, same table we can also use for concave lens. Right? So right now, just don't worry about that one. Right? Okay. Then one more thing we learned in the case of mirror was this one. Important formula: 1 upon F is equal to 1 upon V plus 1 upon U, where U and V are the image and our image distance and object distance, and F is the focal point, focal distance, we can say, of the mirror. Again, remember the sign conventions I told you about. Those are also important, right? Sign convention, what those says, on the left side all the things will be negative, and on the right side it will be positive. Upright, if the image is upright or above the principal axis, principal axis means this part is axis, right? Principal axis, you can see. Upward, all will be positive. Downward, all will be negative. Very simple. And we can use this normal formula. Also, focal distance for the concave, we have written this in the previous section also. Focal length for the concave mirror is negative. For convex lens, it is positive. And one more formula we had here for the lens, the mirror, is magnification. Magnification is what? Minus hi upon ho is equal to minus v by u. Now we know the formulas for the mirrors, and we are also going to study about the lenses in this, right? So now we are very clear about this concave mirror, convex mirror, right? We can replicate all these results for the lenses also. How that we are going to see in this session anyway. Okay. So now let's start our this session with the refractive index first. So as I said, refractive index is a very important thing for us. And first of all, we will see what is refraction, right? Okay. So consider there are two mediums, right? So first of all, let's see what is refraction. Then we will move to our laws, right? So consider in the mirror, if you do remember, this is the mirror, right? This is called as normal. Normal is what? Always perpendicular, right? then if I draw some incident ray like this, I'm going to get the reflected ray. This will be our incidence ray, incident ray. This is what our reflected ray, right? We know this part. Now, this is the mirror. Mirror is going to do reflection. That part is very clear. Now consider, instead of using this mirror, right, what I'm going to do, use the normal slab. It could be a glass slab, right? Right. So this is the slab, we can say. So we just have to use the second material here. You can consider like that. So this could be glass or water, right? Glass or water. But can we say it is it has some different properties from air, obviously, right? So can I say it is denser material? Yes. So we are going to differentiate these two mediums. This medium, let's call this as medium 1. And this is our medium 2, right? So this is medium 2. So if I consider the medium 1 as air, let's say this is air, can I say this is more rarer and this is more denser, right? Denser means it has more density, obviously. It's not necessary that light incident ray will pass from, let's say, rarer to denser. Sometimes it could happen that light will pass from denser to rarer, right? So what is going to happen in this case, that when the incident ray strikes on that surface of the medium, maybe it could be glass, water, doesn't matter, right? This ray is not going to go straight like this. Instead, it is going to go like this. It is going to bend towards this normal, remember. So if this is the angle of incidence, this is called as angle of refraction, angle of incidence and angle of refraction. And we already know angle of reflection, right? So now you understood what is the meaning of reflection and refraction. So what is going to happen if the ray bends something like this? Let's remember. So let's take one simple example. Consider you have the water tank, right? Water tank on your terrace, right? What happens if something falls on in the water, right? What you can see, your mom will tell you that go and you have to take it out. Consider one, say one coin is there, one coin is fall into the water, right? If you observe it closely, right, you will see that waters or the surface or the bottom of that tank, or we can say that coin. Consider if this is the water tank, the coin is here. But if you watch it from this upside, from the top of the water like this, you will believe, right? You will feel that this coin is not here. You'll find it somewhere closer, right? If you just insert hand, if you think, let's say this is your water, this is the coin, right? If you insert hand up to this point, there will be nothing, right? Why? Because the coin is at the bottom, and this is the part, we can say, where you are going to feel that coin is there. But so this is called as, remember, let me call this as apparent depth. Apparent depth. And this whole part we can call it as real depth. Apparent depth and real depth. So coin is at the real depth, right? And you are reaching at the apparent depth, then you are not going to find that coin, or you will not be able to lift that coin. So obviously, whatever you see in that water, it is we can say it is not true. That is not real, right? Why this is happening? This is happening because of that refraction. Or consider, you can do this small experiment, very small experiment at the home also. Take the glass, you can say, right? This is some cup, we can say, or glass, right? Made up of obviously the glass material, right? So you can visualize what is going inside. Fill the water in that, right? And just put one small, or you can say spoon. Just put one spoon here. From the outside, you will see that spoon has bent somewhere like this. Right? Actually, it is not bent, but you will see something like that. You can do this experiment, right, at your home also. Just take the glass of water, put the spoon into that, and you will observe something like that. It looks like a little bit of bent, right? Why this is happening? This is happening because of that refraction, and that refraction and that refractive index, which I said, which is very important for our future physics, right? Okay, so this is something about the refraction. So remember, incident ray will be there, and this ray we can call it as refracted ray, right? In the first case, we have said that it is a reflected ray. Now let's say this is the refracted ray. Okay, incident ray, refracted ray. So angle of incidence, which is called as I, angle of reflection, which is called as R. Very simple. Okay. So now let's move. Now let's talk about the refractive index. So this refractive index is going to tell you that what will be the, we can say, image will look like, and why this spoon is getting bent in that glass of water, or how much this refracted ray will bend towards the normal, right? So all these things are dependent on all this refractive index. So this is very important for us, right? So let's see what is the small definition there. So in optics means light chapter, we can say light section of the physics. The refractive index, which is also called as index of refraction, obviously, or refraction index also, of any material or medium. Also, we can say it could be water, it could be glass, or any transparent material. It's a dimensional less number. It does not have dimension. It is a normal number. It could be 1, 2, like that. That describes how fast light travels through the medium. Okay, so this is the actual definition of that medium, refractive index, we can say, which is going to decide all those properties of the light, right? So if you observe very closely, it decides how fast the light is going to travel. So we know the speed of light. What is the speed of light? It is denoted by, remember, it is denoted by C, 3 into 10 raised to 8, 10 raised to 8 meter per second. But this speed is not in every medium. Remember, this speed is in the vacuum, or air. We can consider air is almost same to the vacuum. So the density is not that much. So we can also use this speed in air also, right? But actually it should be used in vacuum. Okay. So this velocity, with this velocity, we can say the light from the sun is getting towards us. But if you consider the water, the speed of the light in the water will be different, or any other medium will be different. In glass it will be different, right? So how to decide what will be the velocity? Again, it is going to depend on refractive index. So we did very small definition of the refractive index, that it describes how fast light is going to travel through the material medium or any medium, right? So we can see a very small formula is there. Okay? Here, n medium, you can see n is nothing but our refractive index. That is what? It is speed of light. Where? In vacuum. We know the value, right? Divided by speed of light in the second medium. It could be water, glass, we don't care about that. But whatever is the medium, that medium's refractive index we can calculate by this, right? So this is the, you can see n of medium. Obviously it is different for different medium. For water it is different, for glass it is different, right? So again, refractive index is nothing but speed of light in vacuum divided by speed of light in medium. Okay, simple. So just let's do very small calculation. Consider there is one glass material, and we know the light is going, let's say, struck up to this position, and velocity we know c is the velocity, right? After going inside, I also told you that it is not going to go into the straight line, right? It is going to bend something. Let's say in angle r. This is our angle I. Okay. Now tell me, if this material have the refractive index, which is denoted by n, sometimes it is also denoted by ri. Ri means refractive index. right? Let's say it has the refractive index 2, then tell me what will be the velocity of light inside that material medium or that glass. Let's try to use this simple formula. N is equal to what? C upon V. So N is how much? 2. C is how much? 3 into 10 raised to 8. And the velocity I can say. So velocity will become, I have to divide, take the denominator, 2 in the denominator. Tell me whether I'm right. 1.5 into 10 raised to 8 meter per second. Right? So velocity of light reduces in that medium. Right? So remember, velocity of light is also not constant. We can change that in the different medium. Okay, like this. So this is the refractive index. Simple. Now we have studied about the refraction. Here you can see a small diagram. The light is coming. We have they have shown here the very straight line, but actually the light is, we can say this is nothing but the beam of light. This is, we can call it as beam of light, right? So beam of light is coming like this. Medium one is there. C1 means what? C1 is the speed of light in that medium. C2 is what? C2 is the speed of light in the second medium, right? If this is theta 1 they have represented it as I is what? Angle of incidence, we can say, right? Angle of incidence, right? If this normally, what would have happened if that medium 2, something like glass, water was not there? Consider that light would have gone into the straight line like this, right? But now it is bending towards the normal, which is making an angle theta. Theta is theta 2. Let's call this as theta 2 as angle of refraction, right? We know this part now. This is angle of refraction. Okay. So this is our normal refraction. Now we know about this one. Medium 1, medium 2. Medium 1 we can consider it as rarer. Medium 2 will be denser in this case. We can also change those two things. It could be denser to, light could also go from denser to rarer also, right? So this refraction, similar to reflection, reflection has some laws, right? If you do remember, there were two laws for the reflection. We said that incident ray, then the reflected ray, and normal lie in the same plane. This was the first law. And the second law was that angle of incidence and angle of reflection are both same, right? Now, can I say that those angle are same in this case? No, obviously not, right? You can see the angle of refraction, that is theta 2 here they have represented, or R we can say it is now less than the theta 1. Okay. Then so let's try to find out the law and what is the relation between those two angles, right? In reflection, we can directly say those two angles are similar, equal. Here, first law is same. Incident ray, instead of reflected, we are using the refracted ray, right? So incident ray, refracted ray, and normal. These are the three things, three friends we can say. And they lie on the what? They lie on the same plane. So you can see here. Incident ray, refracted ray, and normal. Normal to where interface of two media at a point of incidence, we can say. So this is the normal we have to draw, where the ray is going inside the surface or second medium, we can say, right? So at these three, those three friends, we can say, they lie in the same plane. Okay, so same screen, we can see all those are in same screen. Simple. Okay. So the first law is almost similar to the reflection law. It's only just we have replaced the reflected ray by refracted ray. Simple. Next, the second law, you can see the ratio of sine of the angle of incidence to the sine of angle of refraction. Right? Incidence angle means we can say incidence angle is I, and this is the R, or they have written here theta 1, theta 2. We can consider anything. That's not a case. Right? So let's call the angle of incidence as I, angle of refraction of R. Ratio means what? And not only ratio, sine of the angle. Sine means you must have remember this trigonometric function sine, right? Sine of this angle divided by sine of R is equal to what? Is constant, right? Is constant, they are saying. Now remember, this also constant. This constant is nothing but our refractive index, right? We have seen the refractive index in the previous slide, right? So sine, I can, so I will have the very simple relation there. N is equal to sine I upon sine R. Okay. So we already have one formula for n. If you do remember, n is equal to c upon v, and we got the another formula, n is equal to sin I upon sin I. Now, when we talk about the refractive index, now this refractive index is the relative term. Relative term means what? The n is of this second medium, right? Ray is going in the second medium from the first medium. So I can say this n is actually n is of the second medium with respect to first medium. Remember this part, right? So if you change the first medium, our first medium is air, and let's say, oh, this is glass. If you consider the first medium water and then glass, then also it is going to change everything, right? So this refractive index is a relative term. I'm saying it is dependent on both the medium. So relative index of the second medium with respect to first, right? The formula becomes sin I upon sin R. Or I can write another formula that is C upon V, right? So these are the formulas. I can also attach one more formula here, that is real depth to apparent depth. So what is real depth and what is apparent depth? We have seen this in the initial stage of the session, that if the coin is fall into that your water tank, whatever you feel where is the coin, that will be your apparent depth, and the coin actual is where, that is called as your real depth. Okay, so these are the things you can see. So this is about the refraction and the laws of refraction. Let's move ahead. Now let's talk about the total internal reflection. Okay. So what is the meaning of this total internal reflection? You can say that. But before that, we need some concept of the refraction as well. So we already have seen from when it is going from rarer to denser medium. So from rarer to denser, we are going to get some angle of refraction such that it becomes less, right? You can see here that I is greater than R, we can say, right? But now I told you that it is not necessary that light will always pass from rarer to denser or air to water. It could happen. Consider this is glass, or let's say water, right? And consider under the water you have some source of the light, like this, right? So what is going to happen if the source is here, right? First light will, there are many rays of the light, right? So consider low, this is the bulb which is kept under the water or in some glass material, we can say, right? So this is, let's say, water. Okay. Now consider this second ray. If you do remember very carefully, I told you when the ray of light passes from rarer medium to denser medium is going to bend towards the normal. Here you can see. So one thing, let's mark it, write down, very important. From rarer to denser, refracted ray bends toward the normal, right? And let me make another comment here. From denser to rarer, refracted ray bends away from the normal. So let's see what is the meaning of that. So this is the ray of light which is going from denser medium to rarer medium. Now it is going to move away like this. So this is the I, this is the R. So can I say in this case that R is greater than I? That's right. Okay. Now consider this is the second ray. The R will also increase, right? If the I increases, R will also increase. There will be one point at this point R will increasing, and now it is going to become completely 90-degree here, right? So for some particular angle of incidence, which is also called as critical angle, the R becomes 90-degree. Very simple. Okay. So now tell me, if we increase the angle more than this, what will happen? This R will also increase, and R is now going inside the denser medium. It is never going to come out of the, we can say that water part or denser medium. So if the observer is somewhere here, he will never see that light coming from, because light is the only one. When light hits the retina of our eye, then we can get the sensation of the object. So this observer will never see that there is any object inside. If the observer is here, yes, he will get the light from this one, but this observer will never get, right? So what is happening in this case, this denser medium is there, and even though light is coming, it is not getting refracted, but it is getting reflected, right? It is getting reflected. Therefore we can say this is total internal reflection. So again I will repeat, after some sufficient critical angle, this is called as what? Critical angle, right? You can say this is critical angle. At critical angle, what happens? R becomes angle, R means what? Angle of refraction becomes 90-degree. And if you increase the angle, incident angle more than critical angle, so I can say this is I is greater than IC. Now the R is increasing, or we can say it is never going out of the denser medium, it is going inside the, or inside the denser medium, it is getting reflected. So we can say this is nothing but the case of total internal reflection. Very simple to understand. Okay, good. So now we know that total, what is the total internal reflection. But the very important condition, there are two conditions for the total of reflection, total internal reflection. First condition is the ray should pass from denser medium to rarer medium. Second condition, that incident angle should be greater than critical angle. So these are the two conditions are important for the total internal reflection. Then only we will get the total internal reflection, right? If the incident angle is less than, obviously we can see the R is outside the denser medium or rarer medium. So remember, this should be denser, this should be rarer. Okay, so these are the conditions which should meet for the total internal reflection, we can say. Okay. So where this total internal reflection is used? Okay, so those are actually used in fiber optics. Right? So in the network, internet, we can get that that could use the fiber optics cables, right? So actually, fiber optic cables do what they transmit the data everywhere, right? So through these cables, we can say data is getting transmitted in the form of light. Light actually is the we can say vehicle that transmits the data. Very simple, right? So important thing is that light should never go out of the cable, we can say, right? If this is the cable, light should never get out of it, because light is carrying our data. If the light goes away, our data will get lost there, right? So there should be total internal reflection. How we can get the total internal reflection? For that, you need one thing, that this material, let's say this called as core material, and you can see that's outside material, right? This is the cladding material. This is called as cladding, core and cladding, which should be denser. Our important condition is what? The ray passing in this will get reflected, totally reflected, only if this is the denser medium. So can I say core should be more denser. More denser means what? It should have more refractive index than that of cladding. Okay, then we will get the total internal reflection inside the this tube, we can say. Right. Also, in the second diagram, we can also see some beam of light is going there, but it is not getting in the rarer medium, but it is getting totally internally reflected. Okay, so we can say this is totally internal reflection. Let's move the next part. Now let's come to our lens formula, right? So I told you lenses, there are two types of lenses, right? One lens is a normal lens and other is like this. This is called as biconvex lens or normal convex lens also. And this is called as biconcave lens. So in the diagram, we can see one lens is there. Which one is that? Obviously, it is biconvex lens, right? Okay. So similar to our mirror, I told you that let's go back to our table, that our raw table there, right? This table, we can also use this table for convex lens also, right? If you do remember this table. But some changes we have to do in the lenses diagram there, right? So what changes we have to do? Let's see. So here you can see the animations is that two rays we can say from this object goes and meet towards the real point. In the convex mirror or concave mirror, there was one focal point. For lens, there are two focal points like this. This will be one, this will be second. Also, there will be two center of curvatures. Okay. So let me call this as C and let me call this as C. Same thing. Okay. Only the difference is this one. And also, when we say real, if you do remember, the right side we for the mirror we said that was virtual. In the lenses case, it becomes real. We are going to call this as real, and let's say this as virtual. Right? Conditions are totally same. Conditions means what? If we keep the image as infinity, we are going to get the image in. No, sorry. If we keep the object at infinity, we are going to get the image at the focal length. Very simple. Okay, same thing. But what is happening? The infinity object was at infinity on the left hand side, and we are going to get the image on this focus point, right? Because real we said, right? Real term is also same. Real word is also same in both the mirrors and lenses case. So that table is applicable for both, right? But we have changed the sides. This one becomes real now, and this one becomes virtual. So image in the mirror was we are getting that mirror on the left side. Here they are getting on the right side. So this is the difference. But tables words are similar. We are getting inverted, etc., etc. If we keep the object where we should get the image exactly on the center of curvature, right? But if you do remember, in case of mirror, here we are getting the image, right? At the center of curvature. But now here we have the two center of curvature. Image should be real, so it will be on the right side. Same sides on the center of curvature. Right? So all the things are same. If you keep the image at this particular point, focus to pole, this is the only condition when we are getting the virtual image. So if this is the object, we will get the image somewhere here. Okay, like this. So this is the lenses formula, lenses conditions of the image, which we know that those are similar for as our convex mirror also. Okay, so once you revise the formula, memorize the formulas for the concave mirror, convex lens are same, right? And you memorize the formula for convex mirror, right? Those will be same for our this biconcave lens. And convex mirror biconcave lens will only have one condition. What is the condition? Doesn't matter where you keep the object, right? Image will be always virtual, always upright we can say, and always diminished. Same thing we can use for the convex mirror as well as concave lens. Where is the change? Change is only in the concave mirror and the convex lens, right? Like this. Okay, so this is the lens formula we can say. This is the not lens formula actually. This is the, we can say, our positions, how the image, we will get the image, and what is the nature of the image. So in the exam, they may ask you if the object is kept somewhere, how the image will look like, whether it is real, inverted, or upright, right? So we should know that all these things, right? That table you should memorize that whole table for the concave mirror. Convex mirror is very simple. Similarly, concave mirror, if you memorize the table for concave mirror, you're easily going to understand what is the biconvex lens has to say, right? Like this. Okay. So let's move ahead. Before that, let's write formula for this one. Lens formula, if you do remember, the mirror's formula says that 1 upon F is equal to 1 upon V plus 1 upon U. Lens's formula becomes a little bit different. 1 by F becomes 1 by V minus 1 by U. So only this sign is different here. Also remember the sign conventions in this case. If object is on this side, you know this is U is negative, right? Image we are getting on this side. So can I say V is positive? So remember this sign conventions. One more thing you should remember, for biconvex lens, focal point is, focal length is positive. For biconcave lens, focal point will be negative, right? So using these conditions, we can solve the numericals for this lenses using this another formula. But again, I will repeat, the sign conventions are also very important, right? So if they told you if it is a concave lens or biconcave lens, then always remember focus should be negative. Also in concave mirror, if you do remember, for concave mirror, focus point is negative. For convex mirror, it is positive, right? Remember that part very carefully. Here also in lenses case also, in both the, whether it is convex mirror or convex lens, for convex it is positive. For concave it is negative. Doesn't matter whether it is lens or mirror, right? So remember it like that. And the formula is like this, right? And we also have some magnifications formula, HI upon HO, right? And the formula becomes V by U in this case. If you do remember in the mirror's case, there is a negative sign for minus V by U. Here we are going to directly apply the positive sign, right? And again, we will use the sign convention as per the numericals, right? So these are the lenses where we do use the lenses. Obviously, as at the start we discussed that specs, right? Specs has some properties. Why those specs have some properties? Because this is not the plain window type glass, right? This is our lens actually, right? It could be biconcave or convex, right? So which one should we use? Whether it is concave or convex, that we are going to study in the next session actually, right? So today we just know what is the lenses and what are the biconvex lens and what are the biconcave lens. Image formation, that is important part. We have written the table for concave mirror, that should be used for what? Convex lens, right? The same thing which we have used for convex mirror, we should use that for biconcave lens. Formula, mirror has a different formula. You can just, formula almost similar, we can say only the negative sign is changed here, right? For lens formula, it is 1 by V minus 1 by U. This is the only difference we can make here. Okay. So now once you know the formula of the magnification and the lens formula, we can also try to solve some questions on this. Okay. Okay. So this is the whole theory part of our today's session. What we have studied, what are the refraction and what are the laws of refraction. Refractive index, as I said, is the very important concept in this case. And lenses, what is the formula? Then what should be the focal length for convex and concave? It is positive, negative, right? Like that. What should be the image formation? Real virtual side. So the difference here, real virtual sides are different. That is the important point we should note down, right? Somewhere. Okay. So this whole theory concept we can say. So let's try to solve some questions on that. So first question which is frequently asked is state the laws of refraction. There are two laws. First law says that what? The incident ray, refracted ray, and normal, three frames, right, are lie on the same plane. For the normal, you can also attach some small sentence there. Normal drawn at the interface of the medium where the incident ray strikes, we can say, right? Or the incident ray is there, right? That is the normal. So all those three guys are on the same plane. And the second law is nothing but our formula. N is equal to what? Sin I upon sin R. So this is also the important formula to solve some numericals. right? Let's try to solve one question on this. N is equal to sin I upon sin R. So consider if this is the I, and let's say I is equal to, let's say 30-degree angle is given. Let's say 45 degree, and n is given as root 2. This one is, let's say, R, and you want to calculate the R, right? So how to calculate that? N is given, so just substitute here. Root 2 is equal to what? Sin I means sin 45. Sin R we want to calculate, right? So let's take this sin R onto this side. Sin 45 divided by root 2. Now we should know the value of sin 45 is 1 upon root 2 divided by root 2. Right? When you will see this type of calculations, there are two divisions line, right? This is our important main division line. What to do? 1 by root 2. Replace this division line by multiplication sign and inverse this part. This is root 2 by 1. No? So let's write this as 1 by root 2. So 1 by root 2, 1 by root 2, how much? 1 by 2. So if the sin R is 1 by 2, what will be the value of R? That will be your 30 degree. Okay, so we can say after bending in the denser medium, this ray is going to make 30-degree angle to our normal. Okay, like this we can solve the problems on this one. Okay, then we have also solved one small numerical on the velocities. What will be the velocity, right? If the refractive index is given, if they give you the velocity in the medium, then also you can calculate the refractive index, right? That formula is very simple, C upon V. C, we already know the value of C. How much it is? 3 into 10 raised to 8. If they gave the V, let's say V is equal to, consider, 6, let's say 1. V is equal to 1 into 10 raised to 8. What will be the refractive index? Simple, 3 into 10 raised to 8. And velocity in the medium is 1 into 10 raised to 8. It will become, so N will be 3. Like this, we can solve some questions on this refractive index. Simple. Next, try solve this question. A 6 centimeter object is placed perpendicular to the principal axis of convex lens. Now we know the formulas for convex lens, right? First is 1 upon F is equal to 1 upon V minus 1 upon U, and magnification is V by U or HI by HO. Height of image upon height of object. So first of all, they have given us what? 6 centimeter object is placed perpendicular to the principal axis on convex lens. Let's try to draw the diagram. So convex lens will be like this, which has focal length 15 centimeter. For convex lens, focal length should be what? Positive or negative? It's positive, and this positive negative terms are very important sign conventions, right? The distance of the object from the lens is 10 centimeter, right? So this is the focal length is somewhere here, right, which is at a distance 15 centimeter they are saying, and object is kept here. Always try to draw diagram on this case, right? That will give you the understanding where should be the image. Okay? So once you know that object is between focus point and pole point, let's go back and find out the table of our this one, right? From focus to pole, where should be the image? Image should be upright, virtual, magnified, right? Virtual means what? Now for lanes, I told you for lanes, the virtual side is this one. Virtual means image, you will get the image somewhere here. Upright means it should be upward, right? And magnified, it will be magnified. And also remember all those things. Okay. So once we already know this whole table, almost we will get the what should be the answer, right? Nature of the image, we can say upright, virtual, and magnified. Okay, let's find it out. Okay, and it should be on the left side also, we know that part. Okay, so now what I can write, F is 15 centimeter. What about U? U will be 10 centimeter. It is positive or negative? Negative 10 centimeter, as it is on the left side. Okay, what we want to calculate? We want to calculate position, size, nature, right? Size means also we need to use this magnification formula, but we already know that now the it is magnified, means if the original HO is given, HO is how much? 6 centimeter. So height of the image should be greater than that. We already know that part. Then it is virtual, means on this side, means we, whatever we are getting, it should be what? It should be greater, negative we can say. Why negative I'm saying? It should be on the left side, we know that part also. Size we can calculate. Position, virtual we already know. Nature means whether it is inverted or upright. It is upright, that part also we know. Let's try to use this small formula. So 1 by F. F is how much? 15. V we want to calculate. Minus 1 by U. U is minus 10. Right? Simple. So let's try to solve this one. This minus is going to get plus. And I want to calculate 1 by V. So let's keep 1 by 15 as it is. Let's take this 1 by 10 on this side. That will become negative. Right? Now we know the process. We have to equate the denominator. Denominator should be same. So I can say LCM of this 15 and 10 is 30. So let's multiply this by 2 and let's multiply this by 3, right? So my calculation will become something like this now. This becomes 2 by 30 minus 3 by 30, right? So can I say it is 1 by 30 minus 1 by 30? And as I said, we should be negative. So can I say from this one, V is equal to what? Minus 10 centimeter. Minus sign represents it is going to be on the same side of this one, right? Let's check. Focal length is 15. This is 10. This is something wrong. This is positive. V is like this. U is negative. Plus 10. That will become minus 10. 2 minus 3. Minus, okay, minus 1 by 30 actually. Right? That's what I was thinking, that position should not be same. U and V should not be same. That's why the images are important, right? We know that the image we do get somewhere here, magnified image. So I got the answer as minus 10, but I understood that there must be some mistake I have done. Why? Because if the object distance is also 10, this is not going to happen, that image distance will also be 10. That happens only on one condition, if the object distance is on the, or we can say object kept on the center of curvature. But the center of curvature, I can also say what would be the center of curvature here. Position will be R. If F is given, I know the formula, that will be 30 centimeter. So simple. If I keep the object on 30 centimeter image, I will also get the same answer, that 30 centimeter. You can check if you want. Let's try to do that as homework. You will get the same answer, right? So we got the V. Now what? We want to calculate magnification. What is the formula? V by U. So let's substitute the value of V by U. So this is V by U. V is minus 30. U is how much? Minus 10 is equal to 3. Am I right? Right. This M also have one more formula, HI upon HO, right? HO means object distance is 6, height. So HI will become 3 into HO, or 3 into 6, or 18. We are also getting the positive 18 answer. Positive shows that it is upright, right? So position is where we got the 30. Size what? Size is how much? 18 centimeter. Nature, what I can say about the nature? It is upright, magnified, and virtual. This whole thing we have to write in the answers. Okay, good. So now we know how to solve the lenses problem. Let's find out another, let's solve another one. Concave lens has focal length. Now concave lens has focal length means focal length should be negative 20. We know that part. At what distance from the lens 5 centimeter tall object, 5 centimeter tall, let's write HO is given, that is 5 centimeter. Where from this concave lens looks something like this, right? We know that part. Where is focal point? Focal point is here, that is minus 20. This is minus 20. Now they are asking where to keep the object. We don't know where they have kept the object, but we know where the object must be placed so that it forms the image 15 centimeter from the lens. Now, one thing very important we should know, and that will only we will understand if we know that whole table, right? In the table we say that concave lens acts as a convex mirror. So convex mirror, we can apply that table for the concave lens, and concave concave mirror, concave, convex mirror and concave lens has the same table that says wherever you keep the object, you are going to get the image, which will be virtual, right? So what is the virtual side of this lens? Virtual is this one, right? So this is the virtual side. So can I say wherever I am getting the image they have told me that 15 centimeter from there. So here I'm going to get the image. So object is here, image will be somewhere. I also know that the image is always diminished, image is always upright, right? So we just want the side that HI. So we got the V. V is how much they have given V. Can I say this is 15 centimeter? That's right. And U, they are asking us where will be the U. But I can always say that U will be negative. It's always negative. No? And V is also negative 15 centimeter. Let's use our basic formula 1 by F, 1 by V minus 1 by U. 1 by minus 20, 1 by V is minus 15 minus 1 by U. So what I can do, let's take that 1 by U on this side, 1 by 15 here, 1 by 20 will become minus 9, right? So again, what I have to do, multiply the 15 by how much? 3, 4, and multiply 20 by 3. Okay, so what I'm going to get here, that will become 40 by minus 60, and this is 3 by 60. Both have the minus sign. Can I say this is minus 7 by 60? Right, that's right. Okay, so we are getting obviously minus sign, you will be minus 60 by 7. Here you can keep the object, then we will get the image there. What about the magnification? Magnification is V by U. V is how much? Minus 15. This is minus 60 by 7. Right? So if I do some calculations here, I will get minus L will be gone, 60, or I will get this as 7 by 4. Right? So that should be magnification. Let me check whether we are wrong somewhere. Use this as 50. 1 by 50, 1 by 20. That should have been 1 by 60. No? So use minus 60 by 7 we are getting. Okay. So this should look like our answer. This is nothing but show. Let me check if this answer is correct. 1 by F, this becomes 1 by minus 20. Now this has the minus sign actually. So this becomes plus here. So this is minus 4, this is minus 3. Yes, there is mistake again. So this is plus. We're getting minus 1 by 60. Right? So U will become 60 and magnification will become 1 by 4. Yes. Now we can say the magnification is nothing but HI upon HO. So HI will be what? 1 by 4 into HO. HO is how much? 5. So HI will be 5 by 4 centimeter. Right? You can see this is diminished. Then on the virtual side, etc., we can write all those things. They have just asked us the size. So size will be how much? 5 by 4 as it is diminished. Right? Again, how I understood there is a mistake, because I got the magnification as what? 7 by 4. 7 by 4 is greater than 1. But I know from the table that the image should be diminished, it should be smaller. So magnification should be less than. Therefore, I rectified the mistake. Where was the mistake? Then I understood that this should be a minus sign. Okay, so this is how you can, if you do know the table and the position of the images, objects, you will be able to easily solve the problems, also rectify your mistakes here. Okay, good. So that's our third session. We have studied about the lenses, refraction, and refractive index, right? All those things. So in the next session, we are going to study the very important part, that is eye, about the eye and eye defects. Why we do have specs? We do need that specs. What is the properties of the eye? How we can see the objects, right? Those parts in details we are going to see. Okay. So we'll stop here today. If you do have any queries, please post them on forum so I can answer them. Okay. So we'll stop here. Thank you very much. Have a nice day.